Hey guys, welcome back to another video. So in this video, we're going to be talking about formation reactions. So formation reactions are really important in thermodynamics just because it's a standard way of sort of manipulating reactions. And it's used sort of as a standard way just to, quantify enthalpies and free energy reactions and stuff like that. So the difficult thing about formation reactions isn't really the big picture, it's like the really small details. A lot of people sort of miss some of these problems just because they don't know what these small details are. So I think it's worth it to sort of take a look. So formation reactions have two basic requirements. The product has to be unimolar. So let's say you have a reaction, 2A plus 3B forms 2C. Well, let's say this is a balanced reaction. Okay, let's say it is. Even though it's a balanced reaction, there are two of C's, which is incorrect. That's not a correct formation reaction. So a correct way to actually put this would actually be to divide everything by 2. So you get A plus 3 halves B yields C. Another requirement that's a little more detailed than that is that the reactants have to be in their room temperature states. The reactants also have to be their elements. So the sort of room temperature states I'm talking about are, so let's say you have carbon or something. In room temperature, it's solid. So this can either be in terms of phase, like solid, liquid, gas, or it can also be in terms of whether it's diatomic or not. Also, like I said before, these reactants have to be elements. If they are molecules or compounds, then it's completely wrong. So now that we've kind of looked at the details, let's do a few problems about it, just to make it a little easier to understand. So our problem here is to look at these three problems and see whether it's a formation reaction or not. So let's go through it step by step. So here we have hydrogen and it's diatomic, which is correct, and it's a gas in room temperature, which is also correct. Chlorine, same thing, it's diatomic and it's a gas in room temperature, which is also correct. But see here we run into a problem. The 2 shouldn't be there. It should be unimolar. It should just be HCl by itself. No 2, just 1. So this is wrong. So the entire thing is wrong. But let's fix it. The fixed reaction, or the true formation reaction, is this. And these are all gases. So this is correct. This is the correct reaction. It doesn't matter if these values are non-integers. It just matters that there's 1 mole here and they're all in their standard states. So this is the correct reaction. So let's do the next one. Silicon is solid in its room temperature state. Fluorine is diatomic and a gas. This is also true. There's only 1 of this, so this is also correct. So this is a correct formation reaction. Let's do the last problem. So right off the bat, we see that these aren't elements. You notice the reactants have to be elements. So this is a compound, this is a compound. So this is automatically wrong. But again, we can fix it. So the 3 elements we see are calcium, carbon, and oxygen. So calcium in its standard state is a solid, and it's not diatomic, it's separate. Carbon, same thing. It's also solid and separate in its room temperature state. Oxygen is a little tricky. So we know it has to form calcium carbonate. And it has to be balanced too. So calcium, calcium, carbon, carbon. But there are 2 oxygens here and 3 here. And we can't balance this. We can't change the coefficient here. So we have to add a 3/2. Because 3/2 times 2, 3/2 times 2 is equal to 3. So we have actually 3 oxygens here, 3 oxygens here. This is the correct formation reaction. I hope you guys liked the video. See you in the next one.